Okay, this is on section 7.1 of the pre-algebra book. It's about solving two-steps equations. So we've solved simple equations before, but now what we're going to do is, again, this is about solving two-step equations. And we're going to remember our basic rules that we've always followed. Namely, that we're going to remember that our goal is to get the variable by itself. In other words, isolate the variable. And whatever we do to one side, we're going to do to the other side. So, for example, let's say I have an equation like 4m plus 5 is equal to 25. Now, I know what my goal is to get m equal to a number, okay? So what I'm going to do is do things to both sides of the equations until I get that. Well, normally we add or subtract first, so I'm going to subtract 5 from both sides. I got 4m plus 5 minus 5, that's simply equal to 4m. And 25 minus 5 is 20. And now what I'm going to do next is, I want m by itself. I have 4 times m. I'm going to do the opposite, or the inverse of multiplication, which is division. I'm going to divide each side by 4, and I get m is equal to 5, and that's my solution. Notice that my equal sign goes straight down. Notice I've shown what I've done on both sides of the equation. Now, I can check it by doing this. I rewrite the equation. I'm saying that m is equal to 5. So what I'm going to do is substitute 5 for m. So here's m. Now instead of m, I'm going to put 5 times m, or 4 times m, I'm sorry. So 4 is already there. M is 5. So I have 4 times 5 plus the 5 is equal to 25. Again, all I did was substitute 5 for the m because that's what I'm saying it is. Well, 4 times 5 is 20 plus 5. I'm working down independently on both sides. And I have 25 on this side. That sort of looks like a not equal sign, but it's not. We're testing it now. And then I get 25 is equal to 25. That's a true statement. Since that's a true statement, it does check. Okay? And so that's one way to solve simple two-step equations. Let's try another page here, and we will do another problem to get a little bit more practice. Let's say I have an equation like 15z plus 7 is equal to 52. Okay, so there you can see that up at the top. So 15z plus 7 is equal to 52. I'm going to subtract 7 from both sides. Again, my goal is to get z by itself. Whatever I do one side, I do the other side. Now I have 15z is equal to 52 minus 7. It's a 4, 12. I get 5. I get 45. Divide both sides by 15 to get z by itself. And then I get z is equal to 3. Okay. I'm going to try one now with a fraction. So I'm just going to go over here. This one will be over here now. I'm going to try w over 7 minus 5 is equal to negative 3. Okay, so that's right up at the top there. I'm going to add 5 to both sides. Let me get this straightened up a little bit. I'm going to add 5 to both sides. I get w over 7 is equal to Negative 3 plus 5 is 2. I'm going to multiply both sides by 7 because I want w by itself. So right now it's w divided by 7. I'm going to times it by 7. I can put that over 1 if I would like to. And this side I'll put 7. These cancel. So on this side I just get w. And on this side I get 14. Okay, so w is equal to 14. I could check that just like I did before. Okay, so those are a couple of examples. Let's do another one here. I'm going to do one down. I'll draw a line here. I'll do one here. This is 25 is equal to 7 minus t over 5. Okay? Now, I want to get that t by itself, so I'm going to subtract 7 from both sides. I get 18 is equal to negative t over 5 times each side by 5. Put that over 1 if I want. Cancel. But you know what? That's going to give me a negative t, or opposite of t. I don't want that. So instead of multiplying both sides by just 5, I'm going to make it negative 5. Multiply both sides by negative 5, because then I have a negative times a negative is a positive. So I get t on this side, and on this side I get 18 times 5. 18 times 5, well, that would be like 10 times 5 is 50, and 5 times 8 is 40, so that must be negative 90. And usually I like the t on the right side, so I can go put t is equal to negative 90. Okay? So there are some examples of two-step equations, and with that, I'll end this video.